This is the Unit 5 test study guide. Unit 5 is on polynomial functions. So we've got a handful of different topics here. First one is on classifying polynomials and polynomial operations. So you classify polynomials based on how many terms they have and then what the largest degree term is. So this first one, your highest degree term right here is a negative 2x squared. The squared makes it a quadratic, and there are two terms that makes it a binomial. So we would classify this as a quadratic binomial. Next one, you see that the highest exponent here is a 5. That makes it quintic. And then since there are 4 terms, we just consider that to be a polynomial. Anything more than 3 terms, we don't have a specific name for it. So this is a quintic polynomial. And number 3, it's just got 1 term, that makes it a monomial, and it's the 3rd degree, so that is a cubic monomial. Okay, next section, we're simplifying expressions here, so we've got a lot of different properties, different exponent stuff for the monomials, different rules for the polynomials. So this first one, we've got what's technically just a monomial, because there's no addition or subtraction separating out the terms at all. All right, so what we want to do is follow the order of operations, so this exponent comes first, and when there's no addition or subtraction, you just raise everything to that power. So start by raising the negative 4 to the 4th power, so that would come up positive, and if you raise it to the 4th power, 4 times 4 times 4 times 4 is like 16 times 16, so that would be 256. M to the 2nd raised to the 4th power, you multiply 2 times 4, the power comes out as 8, and then n to the 4th power times, and then we'll combine up all our like terms here. So this is sort of like the associative multiplication property where we can regroup the way that we multiply them. So multiply 256 times 1/6. So that will put, let's see, 256 times 1/6. Does not reduce down, but they're both even, so you can reduce them down to 1/28 over 3, and then we'll see what else we end up with in here. So m to the 8th combined with m to the negative 10th, you would add those exponents, and we get m to the negative 2nd. N to the 4th, n to the negative 4th, you would add those exponents, and they come out as 0. Only other thing we want to do is remember your negative exponents should never appear in the numerator, so we're going to flip that down to the denominator, and it will look like this. All right, number 5 is adding 2 polynomials together. You basically just combine like terms. The signs just stay as they are because it's addition. So 8a squared plus negative 7a squared, that would just be an a squared. And then let's make sure we do the a term next because it should be written in standard form, which means decreasing order for the exponents. So negative 8a plus negative 6a would be a negative 14a. And then negative 6 plus positive 1 would end up being a negative 5. And that's as far as that one goes. This next one is subtraction, so be careful here. The highest term is a 3rd degree, so we know it's going to be a cubic. There's no cubic here, so it's nothing minus negative 2x cubed, so that comes out as a positive 2x cubed. And the squares, negative 7x squared minus 5x squared. So negative 7 minus 5 is negative 12x squared. Next term would be the x's, so here we have a 6x minus 2x, so that would be 4x. And finally the constants, positive 7 minus negative 1, so that comes out as 8. Okay, next we have just basically simplifying some expressions here. So y plus 4 raised to the 3rd power. Remember, you cannot, if there's addition like this, you cannot just cube the y and cube the 4. It unfortunately doesn't work like that. So what we do have to do is write it out 3 times, and we'll do some triple foiling here. While I'm writing that out, I can distribute the negative 2y. So negative 2y times y is negative 2y squared. Negative 2y times negative 1 is a positive 2y. So that'll just get combined with whatever terms we end up with here. So these, when you FOIL these two out first, so y times y is y squared, outside is a 4y, inside is a 4y, so that combines as an 8y. Notice this is going to end up being a perfect square trinomial because these are identical. And then 4 times 4 is 16. So that will get multiplied by that term again. Nothing we can do with these because they're not like terms. So let's FOIL all that out one more time, and then we can combine like terms for our final answer. So y squared times y is y cubed. Y squared times 4 is 4y squared. Next term, 8y times y is 8y squared. 8y times 4 is 32y. Next, move to the 16. 16 times y. 16 times 4. And then we still have, sorry, kind of sneaking these on here. We still have those other two terms as well. So for final answer, just combine like terms. Our biggest term is going to be a y cubed. So we have just the one y cubed. I'm going to keep track of them as I go. The y squareds, I have 4, 8, and -2. So that would be 10. Okay, and then for the y's, I have 32, 16, and 2. So that adds up to 50 for the y. And then there's just that one constant, just 64. All right, so number 8, we move on to our next operation of multiplication. So this is what I'm doing here. I basically just practiced here. So it's like foiling and then combining like terms. So start with a 3k. 3k times k squared is 3k to the third. 3k times -k is -3k squared. 3k times 7 is 21k. And then we move to the -6 and do that process over again. So -6 times k squared. -6 times -k, and -6 times -7, like that. All right, and then just like we did with number 7, combine up our like terms. This is the only k cubed. I have a -3k squared and a -6k squared, so that's -9k squared. My k's, I have 21 and I have 6, so that would be 27. And my constant, just the 42. Okay, next one is division. So you're dividing a polynomial by just a monomial. So you basically just take turns dividing each one of those by the monomial. So first one, each term, piece by piece, -8 divided by 8 comes out to be a -1. C to the 6th divided by c to the 2nd, you subtract those exponents, we get c to the 4th. D to the 4th divided by d, again subtract, we get d to the 3rd. Next, term by term again, 56 divided by 8 is 7. C to the 4th divided by c to the 2nd is c to the 2nd. And d squared divided by d is just d. Last term, -24 divided by 8 is -3. C squared divided by c squared will cancel. D divided by d will cancel, so that just leaves a 3 in that spot. All right, and that is your final answer for number 9. Our second topic, graphing polynomial functions. So this one, we're determining the end behavior, talking about that whole like plus and minus infinity thing. That's what we're doing with this section. So these ones, the end behavior is going to be the infinity on both ends. So like this arrow right here, on the right side, we start by saying as x approaches infinity, and then you basically say where the arrow is going. So if the arrow is going down, we say that f of x approaches -infinity. Then the left arrow, we start with as x approaches -infinity, and then you can see the arrow is going up. So we say that the function approaches +infinity. So you start with that. Determine whether the function is even or odd. Because these two are opposites, the arrows head in opposite directions. This means it is an odd degree function. And then the sign of the leading coefficient, that is based on the right arrow. The right arrow goes down, so the leading coefficient would be negative. All right, number 11, we're doing basically the same thing. So we start with the right arrow. We say as x approaches infinity, so that's the right end of the graph. This arrow is going up, so we use +infinity there. Then we talk about the left arrow. So the left arrow starts off like this, and then the left arrow also goes up, so this would be a +infinity. Even or odd degree, these two match, aka the arrows go in the same direction, so that makes our degree even. And the sign of the leading coefficient is based on the right arrow. The right arrow goes up, so this is a positive even function. All right, let's look at our next page, same topic. we are graphing the functions and then identifying key characteristics. All right, so this first one, and we are just plugging that into Desmos, graphing calculator, whatever you prefer. I'm going to pull Desmos up and use that. Okay, so normally you'd be using it on your iPad, but I'm using my iPad to record, so we're going to plug in here. So we have x to the third out of the exponent plus 8x to the second plus 16x plus 7. Do a quick scan, make sure everything's typed in perfectly, and then go over to the graph. You can even get that out of the way if you want to. When you are clicked on the graph, it kind of highlights all the points it thinks you might want to know, so it's not a bad idea to click on all of those points, because those are going to be your x-intercepts, your y-intercepts, your mins, and your maxes. So all those points are going to play into it somehow. So I'm going to take each of these points and transfer them onto my graph. So let me get these right here. So starting with this one, 1, 2, 3, 4, 5, and then just the tiniest bit past 5. Up here, -4 is up at 7. This one is just past -2. It's right around there. And then this is -1 1/3. And then this is about 2.5. So we're just estimating these values, remember. And then this, not quite -1, -0.6. Just an estimate right there. And 0.7 is our y-intercept. Okay, so we go with those. We plot right through, go up and down and back up again. We'll use that for our increasing, decreasing stuff as well. So I'm going to keep this on the screen. I'm actually going to cover it up just so I can use these points for my domain and range and all this other stuff I need to know. Polynomials. Every single polynomial ever has a range of all reals. That's never going to change unless for some reason it's part of a piecewise function. The range depends on where the arrows go. One arrow goes up, the other arrow goes down. That means that my range is all reals. All right, that means it's an odd function, and odd functions range is always all reals. Relative maximum, you've got this little peak in the graph right here, so you use the graph and copy down the ordered pair that matches with this upper peak right here. And then our relative min is this one down here, so we copy down that point. This is all just reflecting everything that we have on the graph. End behavior as x approaches infinity, so that's the right end of the graph. You can see the right end of our graph goes up, so we would say positive infinity. And then this is as we approach the left end of our graph, so that is this end over here, where you can see the graph is going down, so we use negative infinity. Increasing, decreasing, so our graph increases up until it hits this point, which has an x value of -4. So this is what you'd write as your first increasing interval. Then it decreases between these two x values from -4 up until -1.333. So that is where the graph decreases on that x interval, and then it increases again. So we have a little union symbol because you're going to add on another piece from this x value forever to the right. Okay, so that's all the info for that one. For number 13, we're going to just switch the equation here, get rid of that one, and type in the equation for 13. So we have -x to the 4th plus 3x squared plus 2x. So quick double check, make sure everything's typed in correctly. We can then fill the space with this new graph. Click on it so that it can give you all the info it thinks you might want. So plot those points. You can see we've got -1, 0. It's going to be right there. This one is kind of just like snuck in, like right in the middle of that box, and then it goes through the origin. So you're going to have a lot going on right there. And then here, just estimating where these points are going to be. And 2, 0. All right, so a lot happens right here. So it goes up, it bounces off the axis, goes down for just a second, kind of wiggles around like that. Okay, so using these points, we'll come up with all this stuff right here. Domain for every polynomial ever is all reals. There's never going to be a gap or anything like that as you move from left to right, because you'll always have an arrow going to the left, you'll always have an arrow going to the right. Range. If the arrows go in the same direction, your range is not all reals the way that it was for number 12. So you look for either a highest point or a lowest point. This highest point you can see right here is that y value on the graph, and then it goes down. So you would set it up like this. You would say y value such that anything less than or equal to that maximum value. All right, so it should look like that. Relative maxes, so those are your little peaks of the graph. You've got a little peak right here, and then we have another peak up there. So a little peak at -1, 0, and then you have another one at that high point right there. Okay, so 2 ordered pairs for relative maxes. Relative mins, there's just this tiny little minimum point right there. Okay, so we've got that. Our end behavior, it actually goes down on both sides. So as x goes to the right, the graph goes down. And as x goes to the left, the graph goes down. Okay, increasing intervals. It increases up until this point right here. So it increases up until an x value of -1. Then it decreases for just this like tiny, tiny little piece right here. So from -1 to this x value. There's this little decreasing interval. Then it increases again all the way up to this value. And then after that value, it decreases forever. All right, so all of your info should look like that. Next, we are looking at multiplicity of different zeros. So notice these are in their factored form. So we can just use that to immediately find the zeros. So when you have 3x cubed, if you set that equal to 0, you get 0, because there's nothing like in parentheses like that. The multiplicity is based on the degree, so it's a multiplicity of 3. Anytime that you have an odd multiplicity, it is going to cross right through the graph. Okay, next one, x minus 1. That would be a 0 of +1. The degree is 2. And anything that has even multiplicity is going to bounce off the graph. Kind of like this one did, actually. That one kind of bounced off and then went back down. And last one, x minus 8. The 0 would be 8. There's nothing explicitly written, so the multiplicity is 1. And an odd multiplicity says that we are going to cross right through the x-axis at that point. Okay, 15, we're doing the same thing. We've got 3 different values, though. So this -x is another 0. There's no degree written, so it's a multiplicity of 1. And an odd multiplicity will cross right through the x-axis. Next one, x plus 5, or I'm sorry, 5x plus 3. We subtract 3 and divide by 5. So -3/5 is what you would have for that 0. The exponent is a 3. And again, odd multiplicity will cross right through the axis. Last one, if you have x minus 2, the 0 would be +2. And big exponent here, the multiplicity is 8. And anything even will bounce on the graph. Okay, number 16, it gives us the zeros this time. We kind of work our way backwards to what the function would be. So zeros of 0. So we'll start with our f of x equals. So anything of 0 just has an x, and it says multiplicity 2, so it'll be an x squared. 0 of 1 with multiplicity 2. So 1 would be x minus 1. Multiplicity 2 would make it squared. And 5/2, so you don't want to do x minus 5/2, like you don't want to leave it as a fraction like that. Notice this one, the -3/5, the 5 slid in front of the x, and then you had the 3. So if we have 5/2, then the 2 will slide in front of the x, and then the +5 means that you have 2x minus 5. Multiplicity 2 as well here, so that means that this would be squared. So you have all those pieces. We don't actually leave it in this form. Notice this says write a function in standard form. So we've got a lot of things that we need to FOIL out. The x squared doesn't need to FOIL because it's just an x. Each one of these will FOIL, and then we'll FOIL that result together. So for right now, I'm just going to let the x squared stay right where it is, but that will multiply in as the very last step. All right, so the x minus 1 squared, this is the perfect square trinomial pattern. So x times x is x squared. Double that middle term, so negative 2x, and then square that term for a positive 1. Same thing with this next one. So square this, so 4x squared. Multiply and double, so multiply we get negative 10x, double we get negative 20x, and square that last term. So that's where we are so far. So we've got each of them individually factored out or squared, and then we've got a lot to do with foiling those out. And then our very last step will be to distribute that x squared. So x squared just kind of stays right here. We've got a triple FOIL here, so starting with the x squared times 4x squared is 4x to the 4th. X squared times negative 20x. X squared times positive 25. Then we move to the second term, negative 2x times 4x squared. Negative 2x times negative 20x. Negative 2x times positive 25. And then finally we move to the 1. So multiplying by 1 actually just means all three of those terms are going to stay the exact same. All right, we are sneaking some things in here. There we go. All right, so we'll kind of combine like terms and distribute that x squared. So two more little steps here. So x squared is still out front. Now we're going to combine like terms. The biggest one is the 4x to the 4th. Then come the third powers. So here's negative 20. I'm going to keep track of them. Negative 20, negative 8. And that's it. So that's negative 28. X to the third. The x squares, I have 25 and 40. That's 65. And 4 is 69. I think that's the last one. Then the x's, negative 50, negative 20, that's negative 70, and my constant there, the 25. So only thing left to do there is distribute that x squared, so that will up all of our powers. So just add 2 to each of these powers. So we have 4x to the 6th, negative 28x to the 5th, plus 69x to the 4th, minus 70x to the 3rd, plus 25x squared. All right, so that whole thing is a really crazy polynomial that we have. All right, let's take a look at the next page. Next page moves on to topic 3, which is factoring polynomials. All right, so we have 3 different patterns that I want us to have written down there. Difference of squares, sum of cubes, difference of cubes. Those are going to be good ones to have. So this, we do a plus b, a minus b. That's a pretty easy pattern to remember. These ones are a little bit trickier. This one starts with a plus b. Then we square the first one, opposite sign, multiply the values, and then square the second one. This one very similar, just one sign change. A minus b, square the first one, opposite sign, multiply them, and then square the second one. Okay, so those are your formulas. We're going to be using a handful of those. Factor each polynomial completely. So we have lots of different factoring methods here. Technique number 1, and I don't say number 1 because it's going to be the most prevalent or even the most important, but it's always the one that you should look for first, and that is the GCF. So every single time, no matter how many terms, no matter what the terms are, you're always looking for a GCF first. Okay, so these ones, between these two terms, they are both multiples of 3, and they both have an x squared. So you can start by factoring that out. So once it's divided out, this is a 3 and just an x. This one, the 21x squared, is then just a 7. So that's actually as far as that one will go, because the 3x plus 7 is linear, and there's no other GCF there. This one, look for a GCF. 3 and 147 are both divisible by 3. So we'll start by factoring that out. 147 divided by 3 is 49. And then you look, you have 2 terms. So if you have 2 terms, it's likely going to be one of these patterns, unless it doesn't factor at all, like these 2 terms. So this fits with the difference of squares pattern, because these are squares, not cubes. So the difference of squares pattern, n to the 4th is n squared times n squared. And then the negative 49, to make the middle term cancel, would be a negative 7 and a positive 7. We're supposed to factor completely. So this one has the potential of being the difference of squares, but it's not because the 7 isn't a perfect square. So that one stops right there. 19, look for a GCF first. We actually don't have one. 64 only has multiples of 2. 343 is all multiples of 7, actually. So this one, these are cubes, so it's going to fit with this formula somehow. So you want to rewrite it as something cubed minus something cubed. So the 64 is 4 cubed, and then you've got the A. 343 is 7 cubed, and you've got the B. So that way, this is going to go for each A in the formula, and this is going to go for each B. So the A minus B becomes 4A minus 7B. And then the pattern goes like this. You square the first term, so 4A times 4A. You switch the sign. You multiply these two terms together, so you get a 28, an A, and a B, and then you square this second term. So 7B times 7B is 49B squared. Okay, so those are always a little tricky. We have number 20, a GCF there. Notice they both have factors of W, and if you play around a little bit with numbers, you'll see that they both are divisible by 3. So you can take out a 3W. Little calculator work here. When we take 648 and divide it by 3, it leaves us with 216 plus 1029 divided by 3 is 343. And this one still has 3 copies of W. All right, so we got the GCF. This one is a cube, which will make it fit with this pattern here. Both of these numbers are on our perfect cube list. So the 3W stays right here. Here we want to do the same thing we did with this. So 216 is 6 to the third. And then this one, 343, just like we had here, is 7 cubed. And then there's a W as well. So the 6 is replacing the A's, sorry, this one, and the 7W is replacing the B's. So the 3W is still right out there. A plus B becomes 6 plus 7W. Then the pattern goes like this. First you square the first one, so 6 times 6. Switch the sign. Then multiply these values together. So 6 times 7W. And then square the second one. 7W times 7W. It looks like that. All right, number 21, always a GCF first. They both have copies of C and D that we could get rid of. So at least one copy of C, at least one copy of D, and then the 32 and the 162, we can take out a 2. I think that's as big as it'll go. So without all these things, the number is 16, and then we have 4 remaining copies of C, no D's. 162 divided by 2 is 81. No C's, and 2 remaining copies of D. So the GCF will stay out front throughout our entire problem. This you can see is a difference, and these two terms are actually both perfect squares. So the 2CD stays out front. 16 C to the 4th, 16 is 4 times 4. C to the 4th is C squared times C squared. All right, and then we have 1 minus 1 plus, doesn't matter which is which. 81 is 9 times 9, and then D squared is D times D. So that is as far as this one will factor. 22, look for a GCF first. There's no number in common because this one is just 1 technically, but they do both have a P and a Q that we can factor out. So 216, and then no variables for that first one, minus, this one leaves you with a P to the 6th and no Q's. All right, so a couple options here. You're looking at P to the 6th, which could be a square or a cube, but 216 is not a square. 216 is a cube. So I'm going to write it first as something cubed minus something cubed. So 216 is from our list, it's 6 cubed. And then the P to the 6th would be P squared cubed, because remember you'd multiply those together. So PQ up front. And then we start with this. A minus B would be 6 minus P squared. Square the first one, 6 times 6. Switch the sign. Multiply them together. And then square the second one. So P squared times P squared is P to the 4th. All right, number 23. You're always looking for a GCF first. They are all multiples of 2. They also all have a C. So when I divide out a 2c, the first term is c to the fourth, second one is minus a c squared, and last is minus 30, and no variable there. So this one, 3 terms. We've kind of finally moved on to our next set. 3 terms is just pretty much traditional factoring where you have 2 sets of parentheses like this. So c to the fourth we get by doing c squared times c squared. And then the constant multiplying out to a negative 30 and having our middle term be a negative 1 would be negative 6 times positive 5. And you can see when you combine those, you would get a negative 1. Now this has the potential to be the difference of squares, but 6 is not a perfect square. So this one is done. Number 24, look for GCF, but 9, 7, and 16 don't have anything in common, and they don't all have variables. So since there's a 9 out front, we're going to do this as slide divide. All right, so we are going to slide the 9 over to the end and multiply it by the negative 16. So negative 16 times 9 is negative 144. So we start with that. So now that it's just a y, we can do, it ends up being y squared times y squared to get the y to the fourth. And then the negative 144, we want to multiply to 144 and then add to 1. I'm sorry, add to negative 7. So that would be a negative 16 and a positive 9. That multiplies to 144 and adds to negative 7. And then to finish off, you have to do the divide part. So divide, divide. If it reduces, reduce it. If it doesn't, slide it back. So this one does not reduce, so we slide it back. This one does reduce, so we reduce it. And the directions say factor completely, so this first one can actually go farther. This is technically the difference of squares. So 9y squared is 3y times 3y. And then the negative 16 is minus 4 plus 4. This one, people get mixed up all the time. That is the sum of squares. We do not factor the sum of squares, so it just stays whenever it pops up. Number 25, we are on to our 4 terms, which are factoring by grouping. So we have 2 separate groups here. First group has an n squared in common, so you can factor that out. Without the n squared, that first term is just an n. The second term is just a 2. Next one, GCF between those two things. Negative 36 would be a GCF. And then again, leftovers in parentheses. So if you divide both of these by negative 36, the first term is now just an n. The second term would be a positive 2. So now notice these two things are supposed to match. So the other part becomes the first factor. And then you have the matching part as your other factor. The order doesn't matter. This is just what popped up to me when I was looking at it. And then finally, this one right here is the difference of squares. So n squared, we start with n times n. And we still have this third one. And for the negative 36, we have a minus 6 and a plus 6. So that one is done. One last one of these. We've got another set of grouping where we have 4 terms. So you group these two together. 8 and 10 have a 2 in common, and then they each have 2 copies of 2. So leftovers. Divide out a 2x squared, and we have a 4x left behind. Here, divide out a 2x squared, we have a negative 5 left behind. Okay, same thing with these two. 28x, negative 35. They're both divisible by 7. So when I divide out the 7 from the first term, I have 4x. When I divide negative 35 by 7, I have negative 5. So notice, which is a good thing, that those leading terms match. So everything else becomes one term. And the matching factor is the other. Again, order does not matter. So this is the sum, and these actually aren't even perfect squares. So this one stops right here. All right, on to our next topic. If I can get the page, there we go. Topic 4, solving polynomial equations. So a lot of these are going to be done by factoring, just like we've been doing. So these ones you can factor out. This one has a GCF. So it has a 2 and an x squared that we can take out as a GCF. So once you get that out, our leftovers, we have an x squared here. And when you divide out a 2x squared, this is just a negative 24. equals 0. So two different terms. We're going to take each of those two terms and set them each equal to 0. So this one you just divide by 2, and 0 divided by 2 is still 0. And then you can square root. And when you square root, you always technically have the plus or minus. That just doesn't apply when it's 0. So this one, add 24 to both sides like this. And then this time when you take the square root, you are supposed to have the plus or minus because it's not 0. So you start with plus or minus. And then the 24, I can split 24 into 4 and 6. So square root of 4, square root of 6. So those are our values, and I'm going to put the answers in our set notation here. Okay, 28. First step with 28 is we need to get everything on one side of the equation. So we're going to subtract the 64x over like that. Next, we go to factor, and you use whatever factoring methods we just used on the previous page. So first thing I want to do is factor out the x that I see. And then without the x, hopefully you recognize that that's the difference of squares pattern. So the x stays out front. 25x squared is 5x times 5x. And then the negative 64 is negative 8, positive 8. Okay, so this one you've got 3 different setups here. So x equals 0, that's 1 right now. You can take 5x minus 8 and set it equal to 0, and 5x plus 8 and set that equal to 0. So this one, the middle one, you would start by adding 8 to both sides, and then you would divide both sides by 5. So 8 divided by 5 doesn't do anything evenly. This one you'd start by subtracting the 8s like that, and then again divide both sides by that 5. So this one doesn't reduce down either. So for our answers, we again have a 0, and then I'm going to write this as plus or minus just to condense those other two answers. All right, 29. This one, we've got 5 that needs to be subtracted over. So 37. Got ahead of myself there. 37 minus 5 is 32. They are both divisible by 4. So I can factor a 4 out from both of these. So 108 divided by 4 is 27. 32 divided by 4 is 8. If you hadn't done that, you wouldn't have recognized that there were perfect cubes left behind here. So perfect cubes would be the sum of cubes pattern. So I'm going to write it as, so 27x cubed, you write it as 3x cubed. And then 8, you write it as 2 cubed. So I can use those separate pieces to write out my formula. So 4 stays out front. The a plus b becomes 3x plus 2. And the pattern goes like this. Square the first one, so 3x times 3x. That. Switch the sign. Multiply these two values, 3x times 2. And square the second value. So 2 squared is 4. So you've got those 3 setups. We still have it set equal to 0. I'm going to take each one of these expressions and set them equal to 0. One will be more complicated than the other. So this is just a 4. 4 doesn't equal 0, so that's not going to give us an answer. I can take this middle one and set it equal to 0. So first step I would take here is to subtract 2 from both sides, and then second step I would divide both sides by 3. So I end up with negative 2 divided by 3. And this last one I'm going to have to squeeze in here. Whenever you do sum or difference of cubes, the quadratic part should be solved using the quadratic formula. Okay, so I have x equals negative b plus or minus the square root of b squared minus 4 times a times c. And then all of that over 2a. All right, so let me plug some values into the calculator just so I'm not writing every little bit out here. So negative 6 squared minus 4 times 9 times 4x. Okay, so there's a negative 108 under the square root. And then that denominator would be an 18. All right, so negative 108, you can split that into 36, or negative 36, and 3. All right, so let me sneak these out. So 6 plus or minus. So negative 36 comes out as a 6i, and then there's a 3 left behind. All of that over 18. So finally, let me sneak my answer in here. All 3 of these values are divisible by 6. So this would be a 1 plus or minus, and then that other 6 is gone too. 18 divided by 6 is 3. All right, so those are my values. I'm going to sneak them up in the top in our set notation. So we have negative 2/3, and then we also have 1 plus or minus I root 3 over 3. Okay, number 30 is our next one. So look for a GCF. We find one. We have an x squared that can come out. And then in parentheses, I have 9. Oops, I could have taken a 9 too. Sorry about that. Take out a 9x squared. So this is just an x cubed minus 8 in parentheses. We should hopefully recognize that as the difference of squares as well. So the 9x squared stays out front. This I can write as x to the third minus 2 to the third. So 9x squared. And then this, so my a minus b is now x minus 2. When I square the x, I get this. Change the sign, multiply these two values together, and then square the second part, square the 2. Okay, so I have 3 factors there again, 3 things to set equal to 0. So I'm going to start here. So I can take 9x squared and set that equal to 0. First thing I do is divide both sides by 9, which is still 0, and then square root, which is again still 0. Middle one. Here all I'd have to do is add 2 to both sides. That's an easy one. And this one I mentioned with 29, when you're doing the sum of difference of cubes and you end with a quadratic, you want to plug that into the quadratic formula. These numbers are going to be a little bit simpler to work with. So I have this problem initially. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c. Another thing to note is that when you have the sum or difference of squares, the quadratic formula will always give you an imaginary answer. 2, I guess, technically, imaginary answers. So let's get this cleaned up. So I'm going to plug this. Well, actually, I could probably do it in my head. 2 squared is 4 minus, this ends up being 16. So I get a negative 12 over 2. So negative 2 plus or minus. The negative 12, I can take out a negative 4. And the square root of negative 4 is a 2i. And then there's a 3 left behind. So 12 is 4 times 3. And then a 2 right here. So I can simplify that up just like I did with number 29. So let's write our values. So I have 0, 2. And then when this simplifies, the 2's all reduce down. So I have negative 1 plus or minus I root 3, and then technically over 1. So I guess I don't need to write that. All right, 31. This one, nothing needs to happen before I start factoring. It's a trinomial, so I start right with my 2 sets of parentheses. X to the 4th is x squared times x squared. And then to get the negative 20, and add up to negative 19, that would be plus 20 minus 1. Okay, so I have my 2 pieces. I can set them equal to 0. These are going to be quadratics that I can solve with square roots. So I'm going to take x squared plus 20 and set that equal to 0. X squared minus 1 equal to 0. I could have factored this further, but my results will end up the same as long as I remember my plus or minus. So this first one, start by subtracting 20 from both sides. Then I'm going to divide, I'm going to square root both sides. So I get just an x. From the negative 20, I can pull out the square root of a negative 4. So negative 4 would be 2i. Got a 5 left over. Don't forget a plus or minus in your answer. I almost did. This one, you're going to add 1 to both sides, like that. And then take the square root. So this time, don't forget the plus or minus. And the square root of 1 is just 1. All right, so 2 different values there. Technically 4 when they're all combined up. So I have plus or minus 1. I also have plus or minus 2i root 5, which is a pure imaginary number. All right, this last one on this page, 32, I want to start by getting everything on one side. So subtract the 18x cubed, add the 81x. I can set that equal to 0. Very first thing I do in my factoring process is to factor out an x. Notice you do have a GCF here. And then once we have that, this one's going to factor down pretty similar to what we did with 31. So the x stays there. X to the fourth, we do x squared times x squared. And then multiplying to 81 and adding to a negative 18. That would be a negative 9 and a negative 9. Okay, so 3 factors, set them equal to 0. So I get x equals 0, x squared minus 9 equals 0. And then again, x squared minus 9 equals 0. So this is one of your answers. This one, and this one for that matter, I start by adding 9 to both sides. So this is just a repeat. And then I square root both sides. And make sure in your answer you do the plus or minus. Square root of 9 is 3. And this is just, again, a repeat. So I have 3, technically, 3 different answers. 0, and then positive or negative 3. All right, so we've got 2 more of these on the next page, still within the same topic. So this one, number 33, I want to subtract and get everything on both sides. This one is similar to 31 and 32. I'm just going to have to do a slide and divide. So subtract the 5. When I go to factor it, notice you have a 3 out front. The 3 does not divide out of everything, so I do a slide divide. So slide the 3 over here. So negative 5 times 3, like that. And then you factor it, just like it was a normal quadratic. So x to the fourth is x squared times x squared. Multiplying to a negative 15, adding up to a negative 14 would be negative 15 and positive 1. So you start with that, and then you divide this back in. So the 3 that was out front, you're going to divide that back in. So remember, if it reduces, reduce it. If it doesn't, slide it back. So this reduces, and then this one, I've got to slide the 3 back, like that. Okay, now that I'm factored, I'm going to set each piece equal to 0. Like that. This one, my first step to solve it using square roots is to add the 5 to both sides. So it ends up like this. Next step is to divide, I'm sorry, I keep saying that, to square root both sides. When you square root, you start with a plus or minus. 5 is a prime number. It's not a perfect square, so you just leave it under the square root like that. This piece, isolate the quadratic. So the first thing to do is subtract 1 from both sides. Second thing to do is to divide both sides by that 3. So we get this. And then you're going to be square rooting both sides. So I start with my plus or minus. The square root of 1 is I, and then the square root of 3 does not come out evenly. So what I have to do is rationalize that denominator. Remember, since you have a monomial, you rationalize by multiplying top and bottom by the radical. So I have plus or minus I root 3. In the denominator, the root 3 times root 3 is root 9, and that is just 3. So I'm going to sneak my set notation up here. So plus or minus root 5, and not a very good job of sneaking. Sorry, I root 3 over 3 are my other 2 values. All right, last one of these factoring ones, number 34. So notice I have 4 terms here, so I'm going to factor it by grouping. These 2 have a GCF of x squared, leaving us with 2x plus 7. These 2 have a GCF of negative 8, leaving us again with 2x plus 7. The outside pieces are written as one factor. The matching pieces are written as the other. Okay, so one last time, we've got each one of these terms that you can set equal to 0. This one's a quadratic that we can solve by taking square roots. So first step of that is to isolate the square root, which I do by adding 8 to both sides. Next step is to take the square root of both sides. So when I do that, you always have a plus or minus. 8 isn't a perfect square, but I can split it into 4 and 2. So the 4 comes out, the 2 stays under as leftovers. This one's just a linear piece. Start by subtracting 7, like that, and then divide both sides by 2, which does not reduce down, so you just leave it in fraction form. So my solution sets got plus or minus 2 root 2 and negative 7/2. All right, on to topic number 5, dividing polynomials. I don't have specific instructions for like which method you're supposed to be using, so make sure that you practice a little bit of each, some long division, some synthetic division. So let's say for this first one, since it's a 2x minus 3, that's going to be better for long division. All right, so you want 2x minus 3, and then we're going to divide right here. Okay, so remember your leading term does all the work. This just kind of follows behind. So 12x squared divided by 2x means 2x times what gives us 12x squared? And that would be a 6x. Then we subtract, make sure we have parentheses set up, and then you distribute 6x to the 2x minus 3. So when I distribute, I get this, 6x times negative 3 is negative 18x. Carefully subtract. Remember, subtracting means negative 20 minus a negative 18x, that turns to plus. So this would be a negative 2x. Bring down your next term. So then this leading term, again, does all the work. 2x times what would be negative 2x, and that is a negative 1. So set up your subtraction. Take this negative 1 and distribute it to the 2x minus 3. So I get negative 2x plus 3. And when I subtract, these cancel. And then again, careful with the subtraction. That actually makes these cancel as well. So a remainder of 0 means just this would be my answer. So just the 6x minus 1, no quotient to write for a remainder. All right, 36, let's do synthetic division for this one. So we have the 2, so n minus 2 means I put a 2 on the outside of all of the division fun that's happening here. And then I line up my coefficients. In both forms, make sure that you're really keeping an eye out for any missing terms. Neither one of them have them, but just keep an eye out for that. 37 does have a missing term, so I'll make sure to explain how to do that. So 1n squared, negative 9n, and 17. So this, the first constant, just makes its way straight down to the end here. Then you're going to take this, multiply it by this number, and put it in your open spot. Next, these two will combine up. This gives us a negative 7. Then this, again, multiplies by this and goes in the empty spot. And this would be a 3. Okay, so this very last number here is always going to be your remainder. So the remainder gets written like this, 3 over whatever the divisor was. So that's n minus 2. Then you can kind of work your way backwards. If this is the remainder, that means this must be the constant and this must be the first power. So first power would just be a 1n, constant was a negative 7, and the 3 was positive. So that would be how we write our final answer. 37, I'll do with synthetic again. This one, notice something is missing. You don't have a y squared term. So we're going to talk about how to set that up if you're missing a term. So y minus 7, the 7 would go in a little box right here. We're going to line up all our coefficients, making sure to include the missing one. So 1y to the 4th, negative 7y to the 3rd, 0y squared. Don't forget that, or you'll have a domino effect and you'll mess up everything after these first two lines. Negative 2y and 18. Okay, so this process works the exact same way as 36. We just have a few more columns. So first number goes straight down to the bottom. This 1 gets multiplied by 7 and then lined up here. When I combine these up, I get 0. 0 times 7 is 0. When we combine that with the 0 that was here before, we again get 0. 0 times 7 is another 0, but this time we have an actual value to add to it. So we get negative 2. Negative 2 times 7 is a negative 14. So remember, this very last value that we end up with is going to be our remainder. So write that carefully. So the remainder goes over the original divisor, and then you kind of work your way backwards. So if this is the remainder, this one must have been the constant, first power, second power, third power. So The 1 is on the third power. There's no second, no first, and that's our constant. So minus 2, and our remainder is positive. So that is how our final answer should end up written out. All right, on to our last page, our last topic, topic number 6. So we've got operations of functions, compositions of functions. So we have the main 4. So this one, f minus g, you can set up your function f minus your function g. And this is really just combining like terms and making sure that you're careful with the subtraction. So x squared minus 5x squared would be a negative 4x squared. 4x minus nothing is still a 4x. And negative 12 minus negative 2 would be negative 12 plus 2. That comes out as a negative 10. All right, next one, this little dot, not the open dot, is multiplication. So be very careful with the distinction with those two symbols there. Closed dot, multiplication, open dot is composition. So h times g, we've got h times g. When I multiply them, I end up just kind of doing a foiling. Oh, this indicate any restrictions. There are no restrictions in the first 3 operations, add, subtract, multiply. It only comes in with division, so we'll talk about that with 40. So 39, we FOIL. X times 5x squared is 5x to the third. Outside, x times negative 2 is negative 2x. Inside, 7 times 5x squared is 35x squared. And last, 7 times negative 2 is negative 14. I'm going to rewrite it just to put it in standard. So we've got decreasing powers. So the x squared would go next, followed by the x, followed by the constant. So that would be your expression. Remember, I just mentioned with 38, there are no restrictions with multiplication at all. So the domain is still all reals. 40, we have division. It's easiest to set up, but you have to remember that added factor of restricting your domain. So h divided by f means h in the numerator, f in the denominator. So like you do that, like that's it. That's the actual setup there. What you have to remember though is that if the denominator can't equal 0, we have to look and see how the denominator would factor out. So the x squared would be x times x. Multiplying to negative 12, adding to positive 4 would be plus 6 minus 2. So our domain restrictions come in anytime the denominator would be equal to 0. So whatever factors you have in the denominator, you would set those equal to 0 and exclude them from your domain. So my domain would be anything except for negative 6 from this one and positive 2 from this one. So you can write this in either form you prefer. Might as well leave it in the factored form, I guess. 41 is composition. So g of h of x would be this, g composed with h. So this is the function notation. So we use our function g, which is this function right here. And then the h on the inside means your function h is getting plugged into your function g. All right, so we use this function, but in place of this x right here, we're going to plug in this entire function. So 5x squared becomes 5 times x plus 7 squared, and then we still have the minus 2. And then that just gets cleaned up as much as we can. So the x plus 7 squared, that's a perfect square trinomial. So square the x, multiply them and double it. So x times 7, and then double it, and then square the 7. And then don't forget the minus 2 on the outside. We're going to distribute the 5, subtract the 2, and then we'll end up with our final answer. So distribute the 5. 5 times 14 is 70. 5 times 49 is 243. And then minus, sorry, that doesn't sound right. 49 times 5. It's 245, sorry. Let me double check the 5 times 14. Yeah, that is 70. All right, and then minus 2. There we go. So the final answer should be a 243. There we go. And there's no division, so there is no restriction on our domain for that one either. All right, we've got some composition stuff, some operation stuff. This time we're going to be plugging in values. So g plus h of -4. We have g of -4 plus h of -4. So really you just want to evaluate those two separately and just add the numbers together. So g of -4 means you use your function g and you're going to sub a -4 into it. So 5x squared becomes 5 times -4 squared, and then minus 2. All right, so -4 squared, 16. Multiply that by 5, I get 80. Minus 2 would be 78. And then h of -4. H is just x plus 7. So when I sub in a -4 plus 7, that gives me 3. So finally, the operation says to add them together. So I just do 78 plus 3, and that gives me 81 is my actual numerical answer here. For 43, the open circle means composition, and composition is done a little bit differently. Sort of like an order of operations thing. You have to start from the inside and work your way out. So you start with what I just underlined there. We start by finding f of 2. And this is our function f of x here. So x squared would be 2 squared plus 4x is plus 4 times 2, and then minus 12. Okay, so we simplify that up. So 2 squared is 4 plus 8 minus 12. So 4 plus 8 is 12. Minus 12 is 0. So that means that this is a 0. So what I need next is h of 0. And that'll be my actual answer. So h of 0, remember h is x plus 7, so we do 0 plus 7. And that, of course, is 7. All right, very last topic. We've got regression here. So the population in a bacterial, we've got all of these things right here, and we are going to write a cubic function to represent our data. So I'm going to show you guys what that would look like on Desmos. Okay. So remember what we do here is we add a table. We can start putting our data in here. So we've got just 0, 1, and it's going to guess what we're doing here. So up to 5. And then we can type in these values. So 28, 35, 219. Always be very, very careful when you're typing things in. Double check your tables before you actually do anything. All right, like that. So now in our next one, we are going to do y1, and then instead of equals, you do this little stats and little tilde squiggly line here. So we need a cubic function. So you can really do whatever variables you want, but it makes sense to just do a, b, c, d. So a, that is x1 to the third. Then plus, next one I'll use b, x1 squared. Plus, next one I'll use c times x1, and then the constant plus d. Okay, so all of that, take a look at all of these constants right here. So those are our parameters. We use those parameters to create a cubic function. All right, so I'm going to write that down. So function notation, f of x equals, so that is my cubic, so 8 point, and just 2 decimals is fine. So 8.18 x cubed, then minus 35 point, I'm going to go 41 x squared. Next one is my x plus 133.83, that's just the x, and my constant plus 28.08. So that is my cubic function based on the table that I was given. All right, and then one last one here, another cubic function. This time we want to estimate the value. So we're going to come up with a cubic and then do the same thing with a quartic. So let me clear these ones out so I can get new ones. I'm actually going to leave that. So let me add a table. So I'm going to leave the cubic so I don't have to retype all that. So I have -4, 0, 4, 8, 12. It's so good at estimating. Get rid of that 16. All right, so this we have 975, 128, -9, -160, and -893. All right, so that one, the cubic is already typed in and ready to go. So I can just type those ones right in there. All right, so this is my cubic. So I have, for my cubic, f of x equals, so this I can just use, you know, just the one decimal place there. Oh, sorry, this is not going off of the old one. We might have to retype that there. Yes, let's just here pretend like I'm typing something new. There we go. Okay, so there are my new parameters. All right, so we have, those do not look right. I must have something typed in wrong here. All right, I'm going to pause and take a look at these. Okay, I see what's doing it here. So when I added another table, it became x2 and y2. So that means we need to, actually it'll probably be fastest to just turn that into x1 and make this y1. And then that way, the regression will match what I was trying to do. There we go. So our cubic, we've got, that is the first one, so negative 1.68x cubed plus 21.14 x squared minus 97.48x plus 136.91. That's our constant. So we are estimating the value of 8. So f of, I'm sorry, negative 8. So let me sub that into the equation. So we've got negative 1.68, sub in negative 8 to the third, plus 21.14, sub in negative 8 to the second, minus 97.48, sub in negative 8s, and plus 136.91. Oops, all of this should not be in an exponent. Shoot. Okay, let me try that again. Negative 1.68, negative 8 to the third. Let me get out of that exponent. There we go. If you can hear that noise, that would be Owen banging on things. All right, so we've got 3,129.87. That's the first one. And then the quartic, what I'm going to do is I'm just going to sneak in one extra term, and it's, shoot, it's not important that the letters go in order. So when I add this extra term in, I'm just going to make that an E. So I'm going to make it E x to the 4th power, and then plus. Okay, so I'm going to sneak that last one in there. So now, oh, it's probably going to get mad that I used E. Let's just try a different one. Maybe an F. Uh-oh, hold on. Okay, I'm back, and I'm now holding Owen, so bear with me for just a moment. So here is our quartic. Okay. Our quartic function equals, we've got 0.03 x to the 4th. Oh, good. Plus negative 2.09 x to the 3rd plus 21.78 x squared minus 89.58x, and our constant is a 128. All right, so this value is going to get subbed in. Okay, I'm going to put you down, buddy. Okay, so one more. We're going to plug in the 0.03 times negative 8 to the 4th minus 2.09 negative 8 to the 3rd plus 21.78 negative 8 to the 2nd minus 89.58 times negative 8 and plus 128 gives us this value right here, 3431.52. All right, so we want the difference between them. So we're going to subtract minus 29.87. So the difference is 301.65. And it's up by that much. So that would be our last problem.